delete that. All right, good to go. X-intercepts, Y-intercepts. So we've got 5x over 5, and this is negative 12 over 5. So we basically, oh, maybe I jumped the gun a little bit on you here. But just so you know what's happening here is I'm turning the negative 2y to 0, and the 12 technically comes over negative. So if you want to do one more line here, 5x minus 2y less than negative 12, then it looks like the standard form, right? This is general and this is standard. I don't know if you remember that from IPR when you have C over on the other side. So that's where this is coming from. So x is equal to negative 2.4, so it's negative 2.40. And then the y-intercept, it's negative 2y is equal to negative 12. Divide both sides by negative 2. Y is equal to 606. So there's that. Okay. I will be rewriting it down here. So negative 2y less than negative 5x minus 12, right? So essentially the 5x came over subtracting, and you have the minus 12 there. Divide both sides by negative 2. And when you do that, you need to flip the sign. So let's do that first. Okay, you're dividing by negative. Maybe put a star there, right? And then it's y 5 over 2x plus 6. We make a note that this is going to be a dashed line. True above line. So we're going to do reverse shading. So shade below. So we're making sure that we understand that the true region is above, but we're going to shade the false region. So we're saying that we're shading below, and I circle that so it kind of stands out. All right. Then over to this one, I'll do the same thing. So if I ever present an inequality to you that's a little different, like this one here, you should not, that shouldn't stop you from doing what we're doing, okay? Everything is still the same. So this is 4x is equal to 20, divide both sides by 4, x equal to 5, 5, 0. Here we have negative 5y is equal to 20, divide both sides by negative 5. Nothing flips here, okay? When you're doing the intercept, it stays the same. It's negative 4, so it's 0, negative 4. Box that in. There we go. You take this down and you rewrite it. Negative 5y is greater than or equal to negative 4x plus 20. Divide both sides by negative 5. Y, I did this on purpose, right? So that it happens twice, so you don't forget. Flip the sign the other way, right? Then it's 4 over 5x minus 4. They both have a positive slope, so they will both be pointing the same direction. We know that this is a solid line because it has the equal as well. So all the points that are on this line are also true. And we know that, true below line. How come below, Mr. Erickson? Because it's less than. So the true is below the line. We will shade above, exactly. Like you're always shading the opposite of where the true is. Okay, and then you grab a ruler, no sloppy lines, okay? For notes, I don't care. ACs and whatnot, ruler, okay? All right, so and it takes a little longer, but it's just so much better, okay? X and Y. So I look at my intercepts, I go 6, right? 6, the highest Y value, 5 and 5 is the greatest X value. So I'm just going to go 10 in each direction. That's the safest thing to do than just to go bare minimum. So I'm going to go 2, 4, 6, 8, 10. And I'm going to do the same spacing. And here you don't need to use your ruler to do the markings, just approximately, okay? So we're going to go 4, 6, 8, and why not 12? Why not? So that's another thing you can do to save some time, right? If you just label every other one, you're still telling me that the scale is 2, right? I'm going to do the same thing going up and down. So 2, 4, 6, 8, -2, -4, -8. Oh, I forgot the negatives here. So there is your graph, your grid. And now let's go ahead and graph the first one, -2.4. This is -2, right? This would be -3 right here. So I'm halfway, but closer to 2. Okay, that's my -2.4. And then 0, 6 will be up here. Right, those are my intercepts. And I'm going to make sure I look. It's dashed, right? So dashing through the grid. How's that for a Christmas tune? Y is greater than 5/2x plus 6. Right? We label it right away. Shading, let's do it after. The reason why I'm doing after is because sometimes students shade it all and then it's wrong, and good luck fixing that, right? Once you've shaded, it's so hard to fix your grid. So that's why we have it written here, and we'll take care of that in a bit. Let's graph this one. That one is 5, 0, so this is 6. So 4, 6, so 5 is in between. And then we have 0, -4 is right there. And that's a solid line. And watch, we're going to pay attention to where they cross, okay? We just are able to see it here because guess what? That's the corner point. And we're interested in that corner point here. So I'm going to mark it already. If you don't see it, just extend both lines a little bit until they meet. If you have a, like, even if you had this, right, you could already tell that they're going to meet somewhere down there. So just extend your lines until they touch. All right, don't just think that, oh, they're never touching, right, because my grid is not showing it. No, you still are, okay? So here is your equation, because you want to know which one is which, right, for shading purposes. All right, so now we're ready to shade, okay? So we take this first one and it says shade below. So what's going on there? So watch what's going to happen. You follow this one and you shade below. So it's this way. Everything below it, even this other line that's here, it's all gone, right? It's all false. Because now we're looking at the system, not just one, right? So it's all shaded this way. So we shaded everything below this line, okay? And in fact, I don't know how your graph looks, but I'm going to extend this here a little bit more even. And I'm going to shade everything below it here as well. Okay. Now I'm going to go to the other one, to the solid line. And what does it say there? Shade above that line. So you almost want to go a different pattern so you can see everything above that line is false. Everything. So everything above it is gone. Okay. So technically here there's nothing left because it's either false for one or the other or both. So where's your solution region? It is actually right here. Okay. So I'm going to extend this like that and maybe shade it a bit more so it's easier to see the solution region. So this is your solution region. That's the one, because we've shaded what's false, everything that's not shaded is then true. And it's true for both of them. Okay, because none of the lines have that shaded. Okay, so the corner point, you'll write it down here. So you enter both of them into your calculator and you get negative 5.88, negative 8.71. So we use second trace 5 to do that, right? I will tell you that I would encourage you to do that, but I'm not going to take marks off here under a question like this if you don't have the keystrokes, because there's so much more stuff that I'm interested in than this right now. Quite frankly, you guessing this, I mean, you have to have so many things right for you to guess this, right? And it should kind of match your grid as well, okay? Okay, so that's the first one, and I believe there were more questions. There's 2 and 3. I think I will take the time to actually go through it, okay? So if you didn't do the homework, it's going to take you longer, right? I just wrote it down, but that actually takes a while, right? You need to enter both of them, Y1, Y2, find a window that works, second trace 5. And keep in mind that I'm keeping these questions fairly, the values are fairly low, but down the road you'll see that we will be in the tens and the hundreds, like for our scales, like they're going to change. So I'm keeping it low so that it's a bit easier to wrap your head around. Okay. Okay, question 2. Y minus x minus 3 is less than or equal to 0. And we've got 2x plus 3y is greater than negative 6. Just going to check if that's actually accurate. One sign off and everything goes down the drain. So I'm good. So what, with explanations and everything, if you look at the recording, it took 13 minutes to do this, the one we just did. Probably a little less. So I'm thinking 10 minutes for a question like that should be more than enough. So let's try this one here. So we'll graph it. How about we rewrite it, because we're used to seeing it this way, right? So bring the 3 over. And this is already the way we want it. So now we're going to find the x and the y-intercepts. Question like this is 0. So it's negative x is equal to 3. Divide both sides by negative 1. X is equal to negative 3. So it's negative 3, 0. Y-intercept, y is equal to 3. Notice that it's flipped on you. I don't know if you noticed that. It shouldn't matter. Okay, I want you to think as you're doing this. I don't want you to just follow every step I'm doing, right? I want you to think what's happening. Okay, x is equal to 0, so y is positive, y is equal to 3, right? Over here, y is 0, so you end up with negative x is equal to 3. Okay, so it's not a big deal. So y less than or equal, X just comes over and you're done. Solid, true is where? Less than, below. We will shade above. Right? And this one, hopefully everybody's just watching and enjoying the show, right? 2x is equal to -6 divided by 2, x is equal to -3, -3, 0. 3y is equal to -6 divided by 3, y is equal to -2, 0, -2. y is greater than -2x minus 6. Divide everything by 3. Y is equal to -2/3 x minus 2. No signs get flipped here. And this would be dashed. And true is where? Greater than. So true is above, shade below. Notice this too. This one has a positive slope, so line would be going up. This one has a negative slope, so it's going to be a line going down. Okay? So just observations as you do this. And grid. And I look at my values, 3, -3. If I go 10 in every direction, I'll be fine. So 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6, 8, 2, 4, 6, 8, 10, 4, 8, -4, -8, 4, 8, -4, -8. Okay. We're good? What did 0 say to the 8? What did 0 say to the 8? Nice belt. Okay, keep going. -2, 3, right? -3 here. 0, 3 is there. I need you to wake up, right? Solid line. Extended right across. Y is less than or equal to x plus 3. Then this one is -3, 0. So they share that. And it's 0, -2 right here. So we cross there and it's dashed. Don't be scared to extend your lines, okay? So label, solid, dashed. Now I'm going to do the shading. Shade above the solid. Shade below the dashed line. Okay. Oh, Mina did say nice belt. Okay, sorry, Mina, I didn't see that. It doesn't always tell me if somebody's typing. Okay, so this is all false, right? Notice that it's false for this, everything above. It's false, everything below. We did that all up here. And so this is the solution region, all of this. And this is my corner point. Do you need to use your calculator for the corner point? Nope, right? Because you already know that it's -3, right? That's where they both meet. We found out that that's actually a point they share. And so the corner point is right there. This is just from the graph. Okay, from graph, that's right. If you don't trust me, you enter it and you will get -3. Okay, and now we need to answer the question if those points are part of the solution, right? So let's answer that here. Is -3, 0 a solution? So you enter this into both of them up there. Enter into both inequalities. As many as there are involved. Okay? If there are 3 inequalities, you have to enter this into all 3 inequalities. So remember the one up there, the original, I would use the original if I were you. And so you plug in -3 for x and 0 for y. So it's 0 minus -3 minus 3 is less than or equal to 0. This turns into a positive. So that's 3 minus 3 is less than or equal to, so 0. Is this true? Sorry, you can't see that. Is this true? Yes, it is because of the equal sign. So this is true. So far it's doing okay. And then -3, 0, we'll enter that into, let me just get the original there, into 2x plus 3y is greater than -6. So we enter -3 here, and we're going to enter 0 for y and see if that's true. So that's -6. This is 0. So is -6 greater than -6? False. Therefore, -3, 0 is not a solution to the system. Because both of them have to be true, but you're saying, wait a minute, Mr. Dixon, it's right here. It's so close to the solution region. I know, but notice that this line is dashed, and it's not. That means that points on the line are not part of the solution. So if you had picked anything over here, like even 0, 0 is right there, that's totally in the solution region, right? So then both of them would have ended up true, right? And so the other point that I'm asking for is 0, 3. And I'm not going to do it here, but 0, 3, is that part of the solution? What do you think? 0, 3. Yeah, because it's on a solid line, so you're okay. Okay. So and if you wanted to test it, you enter it into both inequalities, and you would get true for both of them. Okay. That's how you do questions like that. Let's do the hardest one of all. The 3 inequality. That one can get really tricky. And you can almost bet that you're going to get one of those on a test, right? A 3 inequality system. So I'm going to write it down and see how you do. Okay, so you should have on your study sheet the special cases. I gave you a chart to know where to shade. So if you need to have that on there, go do it, okay? So let's start from the top here. X-intercepts, all my intercepts, I'm going to find that first. That's 3x is equal to -12. -4, so -4 is 0. There it is. I'm just going to check if, yeah. And then we have -4y is equal to -12. You divide both sides by -4. Y, sorry, is equal to 3. So we've got 0, 3 there. We rewrite it. -4y is less than -3x minus 12. Divide both sides by -4. Oh, I need to flip it because both of them are being divided by negative. And that's 3/4x plus 3. That's a dashed line. It is true is above, shade below. Okay, so I've got that figured out. I'm going to kind of break this up so that we're not mixing it up. X-intercept, Y-intercept. Here we have that 3x is equal to 0. We divide both sides by 3, x is still 0, right? So we've got 0, 0. And yeah. And this side here, 4y is equal to 0. Divide both sides by 4. Y is still equal to 0, 0, 0. What's going on there? Well, we'll see in a bit, okay? And so rewriting it would be 4y is -3x. Divide both sides by 4. Y is less than 3/4x. That's it. We make this one dashed. True is below, shade above. This one is a special case. Look in your notes for that. It's a vertical line. Goes through -4, 0. It's going to be solid just by looking at that. Where's the true region when it's greater than, and it's just x? It's either right or left. It's right, okay? True right, shade left, okay? So if you have your shading figured out and you didn't make any mistakes, the graphing then is the last stretch, right? That's the last part you need to do. And I'm going to go ahead and do that. And I'm going to give myself a bit more room than I usually do. Okay. Got 2, 4, 6, 8, 10, 12, 14, 2, 4, 6, 8, 10, 12, 2, 4, 2, 4, 6, 8, 10, 12. So we've got 4, 8, 12, 4, 8, 12, -4, -8, -12, -4, -8, -12. XY. Soon we're not going to use all quadrants when it's a word problem. So let's start with the first one is -4, 0, 3 is right there. So it's going to be a dashed line, so let's be careful. There's that. The next one, how would you graph something like that? 0, 0, 0, 0, right? What do you do with a question like that? I did this on purpose as well. Remember that you can use your slope. Like, let's go back up here. You can use this slope to help you graph it. It's telling you that you're dropping 3 for every 4 that you're running to the right. Okay, that's what it's saying. So we're going to do that. So this would be 2, 3 here over 4. Okay, use your slope. So it's down 3 over 4, down 3 over 4, and so forth. But we're just going to, all we need is 2 points. This one is just one that goes through the origin and it's dashed. I'll make a note of that, okay? Use slope to find second point. That's my note there for you. Okay, so we've got that. And now we're going to do the vertical, which is at 0, -4. Sorry, -4, 0, I meant to say. And it's a solid. So there it is. Okay, so that's now the puzzle is coming together. Let's shade one at a time. The first one asks us to shade below. Okay, so I'm going to zoom out a bit so you can see the whole thing. Okay, the first one is asking us to shade below, which was this one right here. So we're going to take our pencil and do that. Everything below it is out of the question now. Kind of removed everything. The second line, it's asking us to shade above. So you'd follow the second line and you shade above like this. And so everything above that line is actually gone now. It's not going to be part of the solution to the system. Okay, so you've got this gone, and then the last one says shade to the left of the vertical. So I use a different pattern there just to make my point. I hope not. The true is right, so we shade the opposite. Okay? So where's my solution region? I love these ones. These are my favorite when you have like a little triangle in the middle there. So just write down solution like this. It is in fact this little triangle in there. So you have 3 corner points to find, and that's mostly going to be the case if you have 3 lines, okay? So corner points. What? Corner points. There it is. So how would you do the corner points? And I will actually use my calculator to help to show you this. I can't remember if I showed this in detail. So grab your graphing calculator for now. Enter them. Okay. So we've got 3/4 x plus 3. We've got -3 over 4x. We've got -4. No, I can't graph that because it's not a horizontal line. I tried to trick you there. You graph it. Yours is probably going to look different than mine because I was just doing other stuff. There it is. So which one can you find at this moment? This intersection here is the two diagonal lines. It's that one right there. This one is not showing up on your system, on your calculator. So let's find this one right here. We're going to go second, trace 5, enter, enter, enter. And so we get -2, 1.5. And I'll just make a note that I use my calculator for that one. I mean, we're going to use our calculator for all of them, but that's the one where you can graph them both. Now we're going to find this one. So second, trace 1, right? We're going to use value. And then you're going to enter -4 here because that's the X line. And you're just going to jump from one line to the other. So write this one down. It's -4, 0, which we expected. And then you jump up, arrow up or down is going to give you the next one. It's -4, 3. It's hard to see on the camera right now, but it's -4, 3. So you write that down as well. And we did expect two of our corner points to have the same X value. Okay. So just jump up and down once you've done second trace 1 to get your two different points. And these are your corner points right there. Okay. So the hardest one of them all . And now we're gonna keep going with this. So I've decided to let you do another one. We have to make sure we're very comfortable with this stuff. Okay, very comfortable. Now, I need to say this, okay? Are we always gonna have a vertical line? No, we might have a horizontal line, right? You might have a triangle up here, right? It depends on the situation. You might have 3 diagonal lines. All 3 are diagonals and they meet and you end up with a non-shaded region, which is our solution, right? Any point in here in this triangle, if you were to plug it into your inequalities, it would be true for all of them, okay? So that's that, okay? So here we go. I will graphing systems continued. With 3 inequalities. That's what I'm going to call that. So I will